I wanted to do a quick recording to walk you through a few of the things that you need to begin to put together in order to get the pig game working. So you have a checklist of what you need to put on the form, such as buttons, labels, and so on. You're also going to need some variables, and remember, variable is just a fancy term that we use to mean a named location in the computer's memory that we can control the value of. So we're going to need a variable for the die roll, and we create variables by using dim statements. So we always put the word dim, short for dimension. For some reason, that's what Microsoft chose for declaring variables. And then we put the name of the variable, so we're going to call this die. That's the memory location name. That's the name we want the computer to reference this memory location that we're going to manipulate with. And then we need to put the keyword as. We'll always put dim, whatever we want the name of the variable to be. We'll put the word as and then the data type. So a die is an integer. It's a whole number from 1 to 6. We're going to have a variable to keep track of the player's total score. So I would use something like dim player score as integer. It's going to be a whole number. We're going to need a variable to keep track of the computer's total score. So dim computer score as integer. Then finally, because of the way we've set this game up, we're going to have some type of indicator of whose turn it is. So we need to know if it's the player's turn versus the computer's turn, so that we can correctly bump up the right variable. So if it's the player's turn, we're going to add their values to player score. If it's the computer's turn, we're going to add the die rolls to computer score. And we'll see how to set that up later on in the code. Now you're also going to have to set up a random number generator like you've done for other things, so you can actually go into your secret number game and borrow some of that code, but in this case you've got to make sure the number only goes from 1 to 6. Remember that you have to set a couple of lines of code up for that, because you've got to go up to the very top of the code window to the form level and do that new randomizer line of code. Then you've got to dim your die variable, and then you've got to set all that up. Now, when we dim these variables, you can put dim statements behind buttons, or you can put them at the very top of that code window at that Form 1 level, underneath that Form 1 area. When you put a variable declaration in that form area, that variable can be used by any button, any label, anything, any checkbox, anything on the form can reference that variable, can update it, can use its value. If you declare a variable behind, say, a button, if you declare or dim that variable behind a button, only that button can use or access or update the value in that variable. We call that a local variable. So if I have two buttons and I declare the die behind button 1, button 2 can never reference it. Nothing else on the form can ever use its value, so that can be limiting. But when you declare a variable or dim it at the top under that form line, at that very top of that code window, it is accessible by both buttons on the form, and we say that it is a global variable. Any button, any label, anything on that form can use it. So we'll probably declare all of these variables to be global by declaring them at the top, and then we'll be able to use them behind any button. We also need the ability to have the code make a decision. And the way we do that is to use an if statement. Code is virtually worthless if it cannot make a decision. So before you jump in and start trying to write this, you need to get a fundamental understanding of the very specific format that Visual Basic requires for an if statement. Here is the general format with these little brackets showing you some things. So you won't use the brackets when you really do an if statement. This is just a general format here. What you do is you have to use the word if to start it, and you have to use end if to end it, and you have to end each if statement. Visual Basic is going to require that. It wants to know the exact beginning and ending, the exact block of code that is conditional, that's run under only certain circumstances. The most basic if statement will be if, and then we'll put some condition that must evaluate to true if the code underneath it is to run. So the word if is required. We'll find out how to make these conditional statements. Then we always have to put the word then, that is required, and break these onto multiple lines just like I have it here. Now you're going to put one or more lines of code. It can be addition, subtraction, so any type of line of code that you want, mathematical or otherwise, you can put underneath this if statement. This line of code here will only run if the condition right here evaluates to true. If this condition is not true, if it is false, this line of code will be skipped. The compiler, the computer, Visual Basic will not even look at it. It will not run. So the end if is important so that the computer knows when to stop looking at this condition for determining whether or not these lines of code run, and when to just go on and start executing every line again. So just like you would say something, like you might say if x equals 5, then print out a statement that says x equals 5 in a label. Okay, so if you have a variable and it's holding the value 5 and it's named x, and you say if x equals 5, then do something, that condition is true. But if x had a 7 in it and your condition was if x equals 5, the code that was under that would be skipped. Now the way you're going to do these conditional statements, you're going to use equal sign, less than, greater than, less than equal to, greater than equal to. You're going to use those types of operators for the most part when you're running if statements and creating conditions. Now there are more complicated formats of ifs. There's all kinds of variations on an if. If some condition is true, then run this code. Else, that's just like saying otherwise, do this. So if I want to have a condition here that runs this code, but if this condition is not true, by default run this code here. And again, I still have to put the end if, and make sure you break these onto lines just like I have here. So if x equals 5, I have a variable named x that I dimmed. It's holding the value 5. If my condition was if x equals 5, then print out in a label x is 5. My else would be print out in the label x is not 5, for example. Okay. Now we have an even more complicated way that we can write an if statement. We still have our if, we still have our else and our end if, but if we need to have multiple conditions, we can use else if. That's all one word. Some other condition is true, do something else. Okay. You can also have one if statement inside another. We call that nested ifs. So there's lots of variations on ifs, and they can get very complicated. So let's just look at some simple examples here. Say I have a variable named age that's an integer, and I've set it equal to 17. My most simple if statement might be to check that age to see if the person's 18. If they are, I want to print out you can vote. If they are not 18, nothing will print out. Whatever's in that label will not change. So if the age is 18, print out you can vote and then be done. Since the person is 17, this condition is not true, it's false. The computer takes the value that's in the variable age, it goes to memory, it grabs that 17, and it basically translates it into this. Is this a true statement? Does 17 equal 18? No. 18 equals 18. That's the true statement. But 17 equal 18, that's totally illogical. That is not a true statement. It's false. So when it realizes that, it substitutes the 17 in there. Well, no, age isn't 18. It skips this line here. It looks for the end if, and then it continues on with the lines of code that come after it, but it skips this you can vote. Now if the age is 18, that is a true statement. 18 equals 18. And it changes that text to on that label to say you can vote. So your form would actually change and that empty label would now say you can vote on it. Now here's a little more, let's go back to this being 17. Here's a little more complicated version. If the age is 18, print out you can vote. Otherwise, for every other age from 1 to 17, or even for, now this is misleading, this if statement's not very good, because if the person's 21, it's going to print out you cannot vote. So you always have to be very careful with these conditions. Under this condition, it's going to be logically correct. The age is not 18, it will skip this. It says, oh, otherwise, if they're not 18, print out you cannot vote yet. If the age was 18, it would correctly print out you can vote. The problem is if the person's 21, 21 is not equal to 18. That's not true. So it would inadvertently print out you cannot vote. So what we should do here is say, else if age is less than 18, then you cannot vote yet. And maybe here we should say if age is greater than equal to 18, then you can vote. So we can change these from equality to less than. We can use greater than. If we want to say greater than equal, it is the greater than sign first followed by the equal, and that is less than equal to. And not equal is exclamation point equal sign. So those are your options for checking. You can do equals, less than, greater than, less than equal, greater than equal, or not equal. Those are your conditional operators. Now here's another example. Say I have a variable called num. It's an integer. I've set it equal to 5. If num is less than 3, I'm just randomly making these up here. If num is less than 3, print out num is less than 3. Otherwise, if num equals 4, print out num is 4. Otherwise, any other condition. If num is not 1, 2, 3, or if num is not 0, 1, or 2, if num is not 4, for every other condition, it's going to print out num is greater than 4. Now, I have a slight logical error here, right? For 5, it will correctly print out num is greater than 4. If I make num of 4, it will skip this. It'll come down here. 4 equals 4, yes. It'll print out num is 4. If I make num of 2, it will correctly print out num is less than 3. However, if num is 3, I have a problem. 3 is not less than 3. That's not true. 3 is not 4. That's not true. So it will come down here and say, okay, for every other condition, num is greater than 4. Well, now I've got a logic error. That's not actually correct. So I should really say less than equal to 3 here. And now if I put a 5 in, I get the correct answer. Or I could put a -1 in and I'll get num is less than or equal to 3. So you can see how these can get very complicated, and I can even have one if inside another if inside another if, and so on. We are going to be able to use these if statements to figure out when the players rolled a 1 to skip their turn. We're going to be able to figure out if the players clicked hold and so on. If they've got to 100, we'll be able to say if they've gotten to 100, stop the game, etc. So I will help you with the code on this. It's going to get a little tricky, but we will be using if statements to make this game work.